Greetings, everyone. So this is the Renewable Energy lecture, and I just want to say before we start out that again, renewable energy really isn't an ecological topic, but the consequences of using or switching to renewable energy are ecological topics. So, kind of start out, my views are that renewable energy is completely better. This is my opinion. Um, it's cleaner, and I support the renewable energy sources of switching as much of our economy as we can towards that, and I think it is really needed. So let's kind of go through some of what we're talking about here. So the first type of renewable energy is taking biomass and converting it to energy. Now, this is the first. It's kind of like going back in time, right, to 300 years ago, where we would use wood, and this is, one way that we can use energy or have a renewable source of energy. I would say that it's not fraught with difficulties. Um, we do have better ways rather than open cooking pots, cooking fires like this woman is doing here. We can find ways to burn wood safely, and get rid of the personal health problems, but we're still putting carbon dioxide into the air. And one thing that we can't help from is that anytime you're burning wood or burning biomass, you're taking nutrients from the original soil and removing it, so you're going to have to fertilize that soil that where you were using that biomass. One kind of way in which we're kind of converting biomass to energy is in Sweden. Sweden has really done a lot to base their energy economy off of burning trash. So they incinerate pretty much all of their trash. Um, we'll talk about the consequences of that later on. But they actually import trash from other countries, basically Norway and Finland, and they burn it. But they still need to put all those ashes somewhere in a landfill. So, and a lot of what they're burning is actually organic based trash, paper, and that kind of thing that burns quite well. Um, One of the more newer ways, rather than just burning wood and burning the plants to begin with, is making an energy plantation. So taking corn, sugarcane, sugar beets, and converting it to ethanol. One of the reasons why there's been a lot of research and use of ethanol is that it emits less greenhouse gas when burned. Now, ethanol is just what you find in beer, vodka, wine, all that kind of stuff, and it does emit less greenhouse gas when burned, but also you get less energy out of it. And when you add up the amount of gasoline that uses to produce it, kind of paints a little different picture of whether ethanol is actually a good thing to use. What we actually see is that the net energy gain that you have by growing an energy plantation and making ethanol out of, say, corn or something, you might actually not gain that energy. Now, the reason that is because ethanol has only 67% of the energy of normal gasoline. Okay, so if you were to use E85, which is 85% ethanol, the ethanol, the E85, has to be 72% the price of gas for it to make economic sense, to get basically the same amount of energy for your price. And what that can really do is then um, you know not make it worthwhile for people to be growing this. So what I would say is that it does have a carbon dioxide benefit, right? So there's less when you're just talking about growing it um, itself and then turning it into ethanol, it does produce less greenhouse gases. However, when you think about it in a more holistic sense, the more corn that we turn into ethanol means the more corn we need to grow in other places to either feed our livestock and our people. So there was a famous study that came out back in 2008 that was looking at how much like crops do we need to grow in other places to make up for what we're putting into ethanol. And what we're seeing is that basically that I highlighted these two things. If you're like just burning it, you get a percent for corn ethanol of negative 20% greenhouse gas production. So that's good, right? That's 20% less greenhouse gases produced if you use corn ethanol. But if you include the land use change into it, you actually produce more greenhouse gases, almost twice. If this was 100, that would be twice the amount of greenhouse gases being produced. So, and that, again, this land use change that is driving this thing is basically because we're using a bunch of corn to turn into ethanol, we to produce the same amount of corn that we need for our livestock and our food, we need to grow that somewhere else. So we're making new fields that are growing corn, and that produces greenhouse gases. So let's think about then hydropower. Hydropower has been generally a very successful renewable energy resource. And what it's doing is basically capturing energy from flowing water. Okay, as you know, think of a way as harnessing gravity. So you either have this is the biggest dam in the world, the Three Gorges Dam. It's in China. The reservoir is huge, and the amount of hydropower this creates is quite a bit. But this is a tidal power system in France, where tides are coming in and out twice a day, so that flowing water is spinning turbines in here. Some of the biggest countries that use hydropower or that have most of their power grid based off of hydropower is Norway and Iceland. Norway and Iceland have Iceland is something like 80 to 85%, I think, hydropower, and it does a really good job with it. The thing is, hydropower, yes, does not produce carbon dioxide, but there's other consequences to it that are not so great. One of the main things is sediment retention. So a reservoir, right? So you build a dam along a river, and what it does is it stops the flow of water. That means all of the sediment that was flowing within the stream all of a sudden has no flow and it drops out. And what you see is at the back end of the reservoir, it starts filling in with sediments. That's what these two pictures are. And basically what we see is reservoirs are only pretty much expected to have a lifespan. They're going to fill up with sediment within about 100 years. Now that depends on where the reservoir is built, but it's still a hidden consequence that we don't necessarily think about. Another consequence of hydropower is that when you put a dam up to make a reservoir, you kind of, by definition, prevent floods from happening. And what that means then is those floods. So this is the Red River of the North. So it flows between Minnesota and North Dakota up north to Hudson Bay eventually. And this is one of the, it's really rich farmland here. Because this river, it's flowing through an old lake bed that was a long time ago. And It's extremely flat land, so when it floods for like 20 miles on either side of the river. It's crazy how these floods work. But every time that water floods, it brings a bunch of fertilizer to the cropland. Natural fertilizer, right? Like nutrients are just flowing down there, and it makes the ground incredibly fertile. The thing is, as soon as you put a dam on a river like that, what it does is, and let's say it's a hydropower dam, the estimate is that about 20% of the electricity that you are creating with that hydropower dam will be needed to use to make up for the lost fertilizer that was naturally deposited due to the floods. So when you stop floods, you stop that natural fertilization. You're going to need to make that up somewhere else, and that takes electricity to make the nitrogen fertilizer that we have. So because of all, let's go back to that sediment issue then. Because of all the sediment is dropping out of the river, the water comes out of the reservoir over the dam as being extremely like clean water with no sediment in it. So the river needs to regain its sediment balance, and what it will do then, it will erode and pull sediment from the riverbank, so the river can like deepen here, it can widen, as in here, pull a bunch of sediments from the riverbank, and basically destroy some land in that way. Then there's just losses, right? So land losses. So this is the Missouri River, if you look here, and there's some really big reservoirs. This is, Montana here. This is the entire state of North Dakota. So this is the Fort Peck Dam. This is the Garrison Dam in Lake Sakakawea, Lake Oahe, which runs for several hundred miles up from the middle of South Dakota up into North Dakota. So these dams and reservoirs are huge. There's a lot of land lost in that. Dams then block migration, right? So think if you're like a salmon trying to swim up this Hoover Dam. You're not going to make it, right? That dam is huge. There has been some success with fish ladders. So these are two examples of fish ladders where it basically slows down the water, and it's a longer path that fish can come over here, find this, and swim up it. Certain fish species will use that. So salmon are great at using that. But there's certain fish species that will stay away from it, and that is an example of paddlefish. Paddlefish need to swim upstream to lay their eggs, and because they're very sensitive to electrical currents, they stay away from dams and won't use fish ladders. So what we see is in most of the range of the paddlefish in the US, most of its reproduction is done artificially through like artificial insemination, where the DNRs of several states will go out and catch these fish, and so that we can have a population of them continuing on. It's pretty crazy how much it would effort it takes to keep this one fish alive. One thing I would say is there's a funny little video. Click on it. I'll put the link in the description of the video of an alternate way to help migration of fish. So hydropower, is it a good thing? Well, yes. I mean, there's a lot of benefits to it. It's a renewable resource. It is carbon neutral, but there are some significant drawbacks to it. Maybe one that has less drawbacks to it is solar energy. We have so much energy hitting our planet every day in the form of sunlight. Harnessing that sunlight, though, is a little bit difficult. There's a variety of ways to do that. The photovoltaic cells, that's, the classic solar panels that you see here. There's also thermal heating. So this is one way to do it, where you have a pipe of water running through here, and these dishes, basically these mirrors, reflect the sun all on one spot right along this pipe. Think of it like a giant magnifying glass. so that then it heats that water and they can use that hot water to create electricity. This is a thermal tower system where basically the sun is shining in, and all these mirrors shine all the sunlight at one concentrated spot up on this tower, and it creates an incredibly hot the area that they can use to harness and spin a turbine and create some energy. If you look at the top of Highland Hall, there's a bunch of solar panels that have been up there since the building was created, and it is quite a. I'm not sure if we've met our return on investment yet, but or made it break even point, but it eventually will. Now, solar energy probably has one of the least environmental impacts other than land use. Like there's not that much pollution. There's not that much consequence of it. There's no emissions of carbon dioxide in it. The problem is transport. Okay, so if you were to get if you were to put a solar facility, basically like one giant solar panel, this is in German, this map for some reason, but you would only need this amount of Libya. They chose Libya because Libya has, sun all the time. Or is that Algeria? I'm just realizing, no, that's Algeria. Anyway, you would need a voltaic cell this big if you wanted to power the EU. So all of Europe would need basically a solar power station this big. So why don't we do that, right? That's the question. Why doesn't the countries that get a bunch of sun do that? Why don't we have just one for the United States, one giant solar panel in Arizona that then can power the whole world? And the answer is transmission, right? We cannot move that energy without loss very far, and it won't just doesn't work. So like solar energy, is it good? Yes, absolutely, but there are some significant limitations to use it, and it can certainly work in some areas. I would think that Northern Africa, the entire part of Northern Africa, should switch over to that because they were in prime position to be able to use solar energy. Other places that are maybe towards the poles, Norway, England, they don't get a lot of sunlight, so that might not be the best place for them. And I think that will be kind of like a continuing theme through this, this lecture for sure, but throughout this class is that, certain environmentally friendly solutions are great in certain areas and don't work, certainly in every area. So let's think then about wind energy. We have lots of wind across the planet, but where can we find that, right? And really, what we see is the most windiest areas are, in the U.S., the Aleutian Islands. Well, nobody lives up there, and trying to transport the energy from, a bunch of turbines way out here to Alaska or where people live in the lower 48, it just doesn't work. There's some decent spots for power up in the mountainous systems and the Great Plains, but again, that's not where the people are. The people mostly are like in the coasts, some places in Texas, and then around in the coasts. So transport becomes a big issue. One of the big, real visible things, I should say, about wind energy is bird deaths, where, people, this becomes like an emotional issue when they see the amount of bird deaths that are caused due to either birds or bats, too. Sometimes I think it's worse with bats, of either getting chopped up with really high speed wind turbines, or the lower speed turbines, are safer for these organisms, but they don't get chopped up. But they have this thing called barotrauma, which is pressure wave. Basically, as the wind turbine blade moves, it creates a low pressure area that can basically burst the lungs of birds and bats that are up near these wind turbines. I think though it's really important that this has gotten a lot of press, maybe from like 2010 through 2015. And these bird deaths of 150,000 to 300,000 bird deaths across the U.S. compared to wind turbines is, I mean, okay, that's bad. I don't like that birds are dying, but nobody complains about glass buildings. We have somewhere between 3 million and 1 billion birds running into glass buildings because they, think they don't see that it's, the mirror surface. They don't see that it's not, a solid object, and they run into the glass building and then fall to the ground and die, right? So when we compare to like other ways that we're killing birds, it's really not that big of a deal in my opinion. So is wind turbine, like wind energy, a great energy source? Yes, there are some consequences of it. Transporting it can be hard. The bird deaths are an issue. Some people don't like the towers, that they're too tall, and they might be noisy at times if they're spinning around really quickly. But the newer ones are becoming less and less obtrusive. The third type of, or the last type of renewable energy is geothermal energy. So Iceland gets about 26% of their energy from geothermal. Okay, so that would put 74% of their energy about for hydropower. What they basically do is they use the hot lava, magma underneath the ground to heat water that they can then either use the hot water for themselves or this, use the heat differential to create electricity, heat their buildings, and it's a really great source because it's a really stable, continuous energy source. Unlike like wind or solar can be kind of finicky, and you need backups for that. If it's a not windy day, you can't just not have electricity. If it's a cloudy day, you can't not just have electricity. So it's very stable, but there are some problems with if the water does get out, it can be extremely acidic and cause some environmental damage in that way. Alright, that's all I have for this lecture. Hope you enjoyed it, and see y'all later.